In the previous movie, we inserted a new edge loop on this organic curved shape using the Swift Loop tool. Now we're going to use that edge loop as a sculptural element for controlling the shape of the subdivision surface model. I want to achieve a depression or a notch here, which will then allow me to detach part of the model. I want to end up with a seat cushion and a separate plastic base. Constraints will help us control the transforms as we move those subobject selections around. And the more complex the subobject selection is, the more helpful the transform constraints will be. Currently, we're seeing the subdivided version of the model. Let's select it. And in the modeling ribbon, we want to be in modify mode, so click that if necessary. And also go down to the bottom of the stack by clicking previous modifier a couple of times until we're at the level of the editable poly. If we get in close on this border edge here, we can see that these two faces here are coplanar. And in fact, all of these pairs of faces are coplanar because when we inserted the edge loop with Swift Loop, we didn't actually change the shape or the form of the model. We just added detail. Now we're ready to move that detail around. We can double click an edge loop, go into edge subobject mode, and if we selected that edge loop previously, it'll be selected for us. And in my case, because I inserted the Swift Loop, that edge loop is pre-selected. If it's not selected in your scene, you can just double click on any one of those edges to select the entire edge loop. Now let's try to transform this subobject selection. Grab the Move tool, and by default we'll be in View Coordinate System with Use Pivot Point Center as our transform center. But if you look in the viewports, you'll notice that the transform gizmo is positioned at the average of all of the selected subobjects, not at the object pivot point. Okay, well we can now manipulate the selection just by pushing that in a certain direction, such as up in the world z-axis. And that was a very simple manipulation. It didn't give us a lot of the subtle control that we'll need for fine detail work. And so let me undo that and show you a better way, Control Z. You could attempt to get a better result using different reference coordinate systems or transform coordinate centers, but for a complex sub-object transform such as this, you'll find that the constraints in the Edit panel will be most effective. They'll give you the most control because constraints allow the transforms to operate in the space of the surface itself, rather than in the space of some chosen transform center or pivot point. This means that, for example, we can move sub-objects around on the model and not disturb the existing shape or form. Constraints are off by default, and that's the button on the left with the little X. We can also constrain to edges, faces, or normals. Let's look at constrain to edge first. Constrain to edge works best with vertex selections, so let's convert this edge subobject selection to vertices. Hold down Control and click on the vertex button. And with constrain to edge enabled, just use the Move tool and position those vertices, and they will stick to the existing edges, and we're not disturbing the shape. Let's zoom in really close. We can click and drag on a vertex to move that selection without using the transform gizmo. The Move tool's axis constraints are still set to the z-axis, as shown on the transform gizmo. The z-axis is highlighted. And additionally, constrain to edge is enabled. We're moving those vertices up in world Z while sticking to the existing edges. All right, that's constrain to edge. Constrain to face doesn't really apply much in this situation, but let's just demonstrate it. I'll switch over to constrain to face. Just select one vertex and get in really close and maybe orbit to see that at an angle. As we move that vertex around, we're constraining to the existing polygon faces. We're not just moving along an edge. We want to make sure that we're seeing the result here. So if I move this in its XZ axis currently, then we can see how it's moving around, and it's maintaining the flatness of the surrounding area. These 4 polygons are remaining flat because that vertex is moving in the space of those polygons. Okay, let's undo that with Control Z, get back to where we were, and we've got all those vertices selected once again. We can push these inward by constraining to the local normal. The normal is an imaginary line that sticks out from every surface. So for example, this polygon's got a surface normal pointing out at 90 degrees to it. We can push all of these vertices in relative to the normals, switch over to Constrain to Normal, and once again just click on the vertices or subobjects. We don't really need to use the transform gizmo. And those are now all pushed in relative to the surrounding surface. We might have introduced a little bit of error into the seam over here. We do want to investigate that. We did move those vertices just a little bit in the x-axis. We'll take a look at cleaning that up in the following movie. That's how to use constraints to move complex selections of subobjects.